Hi everyone, and welcome to a new video about web applications and multi-tenancy. In this video, we will describe what is multi-tenancy, why do service providers need to apply it, and how do they configure it on their applications. With the new norm of applications being hosted in the cloud instead of just being running on servers in data centers and serving customers locally, now we do have the applications offered as a service, or we do have the software being offered as a service hosted on the cloud and delivered to customers all around the world through the internet. And of course, these applications are not designed to serve a few number of users like before. These applications are being designed to serve a huge number of users. These applications are being consumed by millions and millions of users all around the world. And with this huge number of users and customers, we definitely now need to think of how will we secure the data of these customers. Since data is now being hosted on the cloud as well, software developers need to think of a new way to secure these data. They need to find a way to secure access to these data in a way that allow only the authorized parties to access their data. They need to limit access to data. Of course, we can't allow a customer to access another customer's data. It's not an acceptable approach for storing the data. So we need to separate and segregate customer data in the cloud. And today, we will talk about how software developers are achieving this goal. So let's take a fictional web application as an example today. For those of you who watched Silicon Valley may relate to this icon. Anyway, let's think together how this web application would separate each of their customer data. To simplify the architecture, let's assume that this application has two layers architecture. One is an application layer, a web application layer, and the other layer is a database where they store all the customer data. Customers will interfere with the application layer, and whenever they want to store or retrieve any data, these data will be retrieved and stored on the database. So for a single customer to access and operate this application, the service provider needs to have an application component and a database component dedicated for this specific customer. So let's assume that we have the second customer and the third customer who now use this application. This would mandate that the application would provide a separate tenant for each of these customers, a separate application and a separate database. For a 3 customers use case, this approach and design may sound logic. We only have 3 customers, so in total we have only 3 applications and 3 databases. But in real life scenarios, this is not applicable at all. Such application may have 1 million customers. Of course, it doesn't mean that the service provider will need to have 1 million copy of the application and 1 million separate databases to store each customer data. Would you imagine the amount of resources that we need to allocate for this application to serve 1 million customers in terms of compute power, storage, and everything? It's an insane approach. Also, the scalability of the application here is insane to achieve. Think this application now has a new feature or it has a bug that we need to fix. Will this mean that we will need to replace the 1 million copy of this application to add the new feature or to fix this bug? Of course not. So the logical thinking here would be, let's have only one instance of the application being accessible for all our customers. So all our customers will access the single instant of our web application. And on the database layer, let's have a separate database for each of our customers. So for customer 1, we will have a separate database for him holding all his data. Same for customer 2 and customer 3. So in this way, we are sure that customer 1 cannot access customer 2 database because they don't have access to it by default. So this is one step on the right approach here, where it's only one application that's serving all our customers. So all the changes, all the upgrades, all the fixes will be applied once on the application layer. But again, we are seeing here a problem with the database architecture that we have for this approach. The capacity here is a problem again. It's insane to have separate database for each of our customers, because for 1 million customers, we can't have a 1 million database separately connected to this application. We cannot have all these rules and all these connections between the application and the databases to serve each customer data requests. So how would we solve this issue of the resources allocation to database, and at the same time, how would we secure the data of each customer, providing the segregation that we were asking about at the beginning? The approach that many of the current service providers have now is that they do have a single database, similar to what they have done with the application. And when they want to store each of the customer data, they tag these data with a specific identifier and link this identifier to each of the records that are related to this customer data sitting on the database. So let's assume customer 1 now is writing data to the application. So application will receive the data from customer and write it into the database. But along with this data, the application will add a new field identifying the identity of this customer. Let's say it's a customer ID or a tenant ID. So this will be written on the database along with the customer identification. So now we can link this data to that customer. The same is applied to customer 2, customer 3, or even customer 1 million. Whenever they write any data to the database, the application is adding the customer identifier to this set of data being written. By this way, we have all the data sitting at the same database, yes. However, we can identify which data belongs to which customer. And on the application layer, we can control access to this set of data based on the customer identifier. So through logical software controls, we now achieve the segregation of customer data. No one will be able to access another customer data because they don't have access to this set of data as long as they don't have access to the customer identifier. So as you can see now, the application is consistent of two components here. The application layer, which is only one, and another layer, which is a database, a single database and a single application. So now let's see how customers will be accessing this application. And although it's a one application and million of customers, how will we provide access to these 1 million customers to that only single application? At the beginning, we agreed that this is a web application, meaning that customers will access this application through the internet. Most of the time, customers will open a browser, enter a specific URL, and then they will be provided access to this application. However, since it's a single application, how will we separate the access for the customers to this single web application? So let's talk about some of the approaches that web developers are now using to provide access for their customers to their web applications. The first one is URL customization. In this scenario, all the customers will be accessing a single URL, which is the application URL. So everyone will be accessing bypiper.com/app. This is where they see the login screen, where they'll be asked about username and password. Remember, today we are not discussing how we will authenticate the users. We may discuss this in another video, but today we are asking about the segregation of the tenants and how each customer will be accessing a separate tenant of the application. Once the customer has been authenticated after validating his username and password, the application now will redirect this customer to another URL, allowing him to access his own tenant of the application. This might be a separate subdomain. So for example, for customer 1, we can have him redirected to another URL like customer1.pipepiper.com/app. Same for customer 2, customer 3. Each one of them will have his own subdomain. Or we can have a separate subdirectory for each of our customers. For example, customer 1 will be accessing the URL pipepiper.com/customer1/app. Same for customer 2 and customer 3, and that's all. So each customer will be accessing a separate subdirectory to access his own tenant of the application. Another approach is the custom headers. As many of you may already know, that HTTP request that is being sent from clients to web servers consist of some headers by default. Standard ones like user agent, referrer, host. These headers are used by the HTTP protocol to provide information being cascaded from the client side to the server side. And the HTTP protocol also supports custom headers. So a server may ask the client about some of the custom headers, and the client will be responding to these requests by providing specific data or specific information to these headers. One example here is for Office 365. When a user or a client is opening office.com, trying to open his own mailbox, for example, the server will be sending to the client these two headers within the HTTP message: the restrict access to tenants and restrict access context. These two custom headers will be empty, being sent from the server to the client, and the response will be coming from the client to the server with the specific customer identification. So the client or the user will be saying, hey, I'm customer1.com. This is my domain. This is my tenant that I'm trying to access on this shared Outlook infrastructure, or this shared infrastructure that provides the information or the mailbox that I want to access. Another similar example here is for Google Suite. The customer will be sending his own domain into this specific custom header, and this way Google will be identifying which tenant this customer is trying to access. Slack has his own custom headers as well. The same applies for Dropbox also, and so on. So each software or each web application will be using his own custom headers that they will use to identify which tenant to serve to this specific customer. That's all I have for you today. I hope you enjoyed and learned something new today, and I will see you next time.